That's crazy. Okay, wait. Okay, I'll just work like this. Oops. The audio's okay. Hello. All right, we're designing a Gundam, Tequila Gundam. Just gonna show off some of the work I've done here. So right now I'm just working on the arm, but so far what we have is the general shape and look. Let me turn everything on here. What happened here? Not sure. Okay, well, something went wrong. Turn on. Can hide that. Cactus shoulder. Okay, so here's what we got going on. I'm pretty proud of the work I've done on the head. So we have the hat. The hat's not done yet, but you can see it's gonna be separate from the head. So let's turn off the hat. So you ever seen the manga? There's a manga where Tequila Gundam he launches his hat. So yeah, the hat can come off. I'm gonna design some slots for it to go into. But yeah, there's the hat. It comes off, and then just like any high grade Gundam kit, you can build the head. So there's the front, and then there's the back half. So it's the neck. So yeah, just turn off the front there, the front half. You can see the ball joint going into the back half of the head. Yeah, it's missing something. There's some things that are missing. Turn the head back on. There's supposed to be a little like triangle here. But yeah, so that's the back half. Here's the front half. And the front half is okay. All right, there it is. Move it to the back. Okay, so okay, if I hide the hat, you can see it's made up of multiple parts. It's going to be a lot of part separation. See, there's the mustache, the mask. Here's the chin piece, the eyes. Okay, so the mustache is going to mount onto the chin piece, and then the chin piece. Yeah, got the eyes. Yeah, they're gonna slide into each other. You're gonna have to assemble it. Definitely gonna have to draw up instructions, but yeah, yes. We got the neck. This is accurate. This neck is accurate. Okay. Let me let me show you. Take a look at this. Look at that shape, the keyhole shape on the neck. That's what we got going on here. Look at that. Okay, cool. We have the classic Gundam pauldron shoulder armor that splits in half and gets stuck into the shoulder socket here. And the torso I'm still working on. It's a lot of pieces need to come together into the torso, and so far I only have the joint design, and this is very accurate to Gundam pieces. So if you didn't know, well, really, yeah, this is my own design. This is gonna be 3D printed and released as a kit, and maybe down the line I'll release the files for, most likely. But yeah, so let me hide the torso here. You can see this is your standard Gundam shoulder joint shape. You know, the L and then the pins and then the little socket here. Okay, we got the collar. Sorry, this would be the collar, and there's the little plate that covers up the neck connection. You can see that here too, in the bottom right corner. Yeah. So right now I'm working on. So what I need to do is work on the connections here in the arms, so that I could start working on the poncho, the shoulder, the poncho, the shield here. It doesn't have a shield in the anime, or actually, I guess, yeah, a lot of them don't. G Gundam uh, Gundams don't have shields really, so this is kind of his. Yeah, so I have an idea of how I want to work it out. So this is gonna. Let me just see if I can use paint, or sorry, snipping tool. So I don't want to overcomplicate anything. Yeah, I want to open it in paint. So I want a classic, like, so this shoulder piece right here, this piece of the poncho, I want it to connect to the socket right here. And then this front plate, this front plate, is going to attach to the, let's color green. Let's color it yellow. So this front plate, I'm going to attach to the red, the shoulder piece, and then the back plate. Back plate it's going to attach to the back side, and I'm going to put like a joint there, joint here, so that you can position the plates away so you can move the arms and pose them a little bit better. I don't want the whole thing to be static. Okay. Alright, so yeah, we have high grade. Well, there's a lot of custom shapes you'll see in here. So there's the hide everything else. There's the shoulder, the deltoid, I guess, the deltoid rubbery piece that goes into the deltoid. There's the deltoid. Here's the bicep. Here's the elbow. Let me hide these actually. And let's turn on the elbow. Hide the cactus forearms. So right now I'm working on these. These come together. I can just show them. There it is. Okay. These come together like this. And then I'm gonna have, there's the inner bicep. So the inner bicep isn't final yet, but basically there's the outer, right? And just like any other high grade, I'm gonna want this piece to slip on the onto this square right here. Slip onto here, and it's going to be a nice press fit. But yeah, I'm working out the elbow. Once I get the elbow, then I can continue working on the inner bicep here. So. And it's going to be a nice press fit. Okay, all right. So I know the stream is working. Okay, so we have let's create a new collection. I just want to be able to turn them all off at once. New inner bicep. Because right now there are multiple pieces, and most likely I'll print them out. I'll leave them as multiple pieces, and whatever slicing software I end up using will probably manifold them all into one. So let's go bicep, inner bicep, so I'm able to flash them all on and off really quick. It's very nice to have a reference like that. So there's the inner, there's the bicep, there's the outer. And once I finish this elbow, I have to make a rotation check, which is like action all the, or just bend the elbow and make sure everything can rotate freely and make sure it doesn't crash into each other. So there, yeah, it's looking pretty promising right now, the arm pieces here. But let's hide the deltoid. And continue working. So I do have a oh my god, I do have a high grade Gundam right next to me, so I do have something to reference, and I do have a digital caliper. Let me turn on the camera. I think that'd be cool. Holy shit! Okay, I just taking up the whole damn screen. So I have a vernier caliper, and I don't want to move my camera, but Gundam pieces for me to reference. And I only use them as a reference because if I copying them directly is not doesn't really work out for me. But yeah, so here's like just took apart everything. But here's the Gundam. Here's our RX 782's elbow. He's in pieces. I also have Destiny Gundam here too. Yeah, so you can like. I like to be standard, you know. I like to keep things standard. Like if there's one shape, I like to keep using it. But yeah, what surprised me was like, I guess it really shouldn't surprise me, but these Gundams, they're all different shapes, right? So yeah, not a lot of reused parts. I guess the only things you really see reused are like the polyethylene, like rubbery parts down there. So yeah, let me plug in my laptop. Let me charge it. So yeah, we have this piece here, and obviously we don't want it to come out this far. It's going to crash into everything. And basically this, it really shouldn't look like that, but let's see. So I guess the idea, so like a lot of my thinking is not original. I just look at the Gundam like it. So basically this, imagine this black line is like the outline of the bicep inner piece. It's gonna look something like this. Exactly the, yeah. You can see the Gundams, the Grandpa Gundams. His thing kind of does that. So yeah, we wanna clear this area here. Have this. There's gonna be like a wall here. It's gonna act as like a backstop to limit the amount you could bend. We don't want his elbow to bend all the way back. But yeah, we have this pivot point, this pivot point. This right here is the not a pivot point, but just another point for clamping down, for closing on, closing the elbow on. So let's hide the B part. Freaking elbow. And I'm actually gonna do the same thing here. I'm gonna group everything. Actually, let's make the group now. Wait a sec. Okay, all right. All right. Okay, let's hide the bicep. And these can go into elbow A. Yeah, elbow A. There's a lot of parts to this. This is crazy. This is elbow B. There we go. We have the ability to see its multiple objects. And just being able to shut them on and off, turn them on and shut them off is pretty nice. Got some parented relations. And hey, so I'm a mold designer by trade, and a lot of the decision making in these Gundams are based on the limitations of molds. So you see like a lot of the walls on the Gundam, they usually stay consistent with 1 millimeter. 1 millimeter, because if you go higher, if you're inconsistent, one, the the flow of molten plastic is very it would be very inconsistent. It would show up in the part. Okay, for lack of a better explanation, but so that's one. And two, any thicker than that, then you get what we call sink. So if you have molten plastic filling up a large cavity, then as it cools off, it's like the outside cools and the inside stays hot. So you have an area on the plastic where there's like some deformation. I don't know. I'm not very good at explaining shit, but yeah, that's why they keep everything 1 mil, and you see ribs. You see ribs, and like yeah, like instead of this being completely solid, for example, they have like ribs, and then like these posts that are only 1 mil around. Yeah, it's all about the properties of the plastic, really. No, no one's listening, man. What the fuck? I want to think of an analogy for you guys. Anyway, let's see if I can find something. Um, plastic sink sink uh, marks. Here you go. Here you go. Sink marks. So yeah, thicker section of the plastic part. There. So yeah, this would be a problem in Gunplas. Yeah, see, longer to cool, cools faster, molecules thicker, blah blah blah. Yeah, man. This is like something that was taught like when I was first starting out, but like becomes something I inherently know, and now I can't really explain it properly. That's weird, right? Anyway, but yeah, you can see the cross section of this plastic here, of this part. So this is like the ideal cavity, and then ultimately this is what was formed after the plastic was injected and cooled off. We have a lot of molten plastic pooled up in this area, and so once the rest of the part is like cooled off and then taken off, you're still left with this very hot plastic that continues to deform once you take it out of the cavity. Interesting, right? That's very interesting. Anyway, so yeah, a lot of the decision making here is to avoid something like that. So like this, like the intersection where the round pin is hitting that wall, like they minimize as much intersection as possible to avoid sink marks. But for a part this small, it I don't know because I don't work with anything this small. I work with car parts. But yeah, you can see like sometimes there's some areas where they kick it up to more than 1 mil. For example, this ball here, this ball joint on the shoulder piece. I don't know if that comes out good. Comes out good. This ball piece. This ball piece right here. This is much. You can tell. Look at it against the. Look at it against the 1 millimeter wall. That's pretty thick, and they still ended up molding it pretty good. Here's the other half. The other half of this ball has a through hole to avoid sink marks. That's how thorough these engineers are at wherever they make them. Bandai. But yeah, for most of these parts, they have a tendency to keep it 1 mil. I'm 3D printing everything. I don't have that limitation, but some you we can apply some of these principles just for material saving. Because at the end of the day, who wants to 3D print like a solid ass, big ass chunk of piece when you can just make it like optimize it so it's the same. It's pretty strong still, and then gets the point across. Yeah. So I mean, there will be some instances where like I would want to make something solid. I have the liberty to do that. Man, look at me fucking yap, man. Anyway, we have this piece right here. I'm gonna turn off elbow B. Turn that off for now. Oops. Separate that. Elbow B. And I want the thickness on the inside, so let's do this. Let's hide this part. So something like that. We have this wall here to just cover up the mechanisms. The internal elbow. Yeah, I might yeah, shave some of this off. Yeah, like right now, like I still don't know what the inner bicep's gonna look like. I just have an idea. We have that piece. Can so the slicing software is gonna do a lot of the heavy lifting here. Like going face to face, like here, right here is. I don't really like doing that, but I'm gonna let the slicing software figure this out and make this unify into one part. So what you see here, it's gonna be one piece, hopefully. And then there's gonna be a post here. No one's chatting. What the frick? What the frick? Extras. So yeah, normally I work on a laptop. All my cool settings are on my desktop. Extra objects. Mesh. Single vert. Yeah, so yeah, again, I really don't know what the shape of this is going to be like. Oh, it's in 4.0. Okay, I gotta be in 4.1. Whoops. Oh, nice. I've never. Oh my god, my computer's going crazy. Okay, I'm gonna turn off the camera. I'm gonna take some measurements of this post here, and then we're just gonna throw it on there. It's probably gonna be like 1 mil by 1 mil. It's 1.3 by 1.5. It's fine. Oops. Yeah, no, that's fine. Let's bring it back into the group. So now we have pretty awesome elbow part here, and then there's the elbow B. Hide the bicep, and yeah, we're let's get cooking with the. Okay, I'm gonna need a cross section of this available to me. So what I'm gonna do, so I'm gonna duplicate this, and let's hide the original, and let's call this one cross section. It's too bad that Blender has no easy way of setting up a cross section. I have to do this. So bicep outer. Let's hide the original. So this one's the one I'm gonna cut in half. Let's apply it as a mesh to save on some memory or whatever. I don't know if these processes are CPU or RAM intensive. But yeah, I have no idea. I probably shouldn't. I should know, but I don't. There's the Boolean object. Just rename it. Bicep cross section. Ooh, I have to design the shell. So yeah, this is kind of a little weird thing with Blender's Solidify. Like, so coming from a CAD background, there's no clean way of getting a nice like thickness to a nice and even thickness to a some like a multifaceted object. So let's say I got something. Hold on. Let's do. This is just an example. So say I got something like this. And with Blender, there's the solidify object, solidify modifier. Well, I guess this one came out cleanly, thus not demonstrating my point. Okay. Shit, that's not really demonstrating my point. But what I'm basically gonna do, okay, is I'm gonna create, because my bicep is a solid object that is closed in on itself, I'm gonna create like a 3D object that I can cut out a consistent 1 mm shell out of that object, out of the bicep piece. So let's see. Oh yeah, here we go. Some like this. Okay. So look at the way this wall, these faces here behave as I shrink this down. So the bicep does taper in a little bit, and you can see like like these edges here are straight along this y-axis. But unfortunately, I don't know how Blender calculates it, but these faces don't end up being straight. So what I end up having to do is fill this in and then create a shell object to cut it out. So let me show you. So let's say, so say this is the bicep, right? I'll duplicate it, create a solidify. Let's say I want it 10 millimeters thick. I'll apply this, and looking on the inside, you see the shell object. Okay, so I'm gonna edit that and delete the outer side, and then you're left with this. And then from here, what you can do, man, this is terrible. Well, first of all, you have to make sure that the object is non-intersecting with itself. So, man, let's clean up the geometry here. So this is the true face up here. So I'm just gonna pull down this vertex. Okay, that's the true face of that 10 millimeter. But you know, it doesn't need to be precise. It just needs to be good enough, because we're working in like we're working nanometers pretty much. But yeah, so what I can do from here, I can extrude out, or going a roundabout way of doing this is like you can take your edge tools and extend past the so this is like a natural extension of all these faces here. So it will look as expected. So actually, let me grab all these. Extend. Okay, and then we go over here and we're gonna delete this face. Like, who's gonna look at okay, so it's gonna make sense in 1 second. So there's a natural extension of all these faces here. Close that up. You can close this object. So I'm using the F key to try and fill in So maybe I'll just manually select it now. So yeah, Blender's pretty smart. Sometimes you press the F key and then it'll interpret a face. So that's my 3D shell object, okay? And we gotta make sure the normals are facing out. And let's find that plane 30. If I can find it. Where is that? Where is it? 0.030. There it is. So we have a shell object that's a natural extension of, so it's a 10 millimeter offset from all these faces. And sometimes when you offset 10 mils, some faces get eaten up as they cross over and intersect with each other actually. So it shouldn't look like this. But yeah, some faces get eaten up, like so then like maybe these corners should meet up and this face shouldn't exist. But for this example, who cares? But yeah, so let's get rid of the solidify. Actually, I'll duplicate this. Remove these faces. We can have a nice comparison. So I'll use the I'll get rid of the solidify boolean, and there's the shell object. So we have a nice consistent 10 millimeter thickness with expected results compared to something like this with a lot of intersecting faces and geometry. This would not be, so I'm doing this because it's for 3D printing and I want some clean results. I don't want to leave it up to the slicer to, interpret something like this and leave me with very poor geometry. But at least with the method I use, it's pretty clean. I haven't 3D printed anything with this method, but I like it. I like the way this looks, and it's quite easy for the slicer to understand. So yeah, that's that example, and that's exactly what I'm gonna do here. So this cross section, just hide it for now. Oops, let's hide it. Any chats? What's up, chat? Uh, so let's hide the bicep outer, and let's work on this guy. So this one's pretty simple. It's a straight piece. I originally had it looking like this. Just to so you can see how rounded it is. And actually, I might come back to this. Oh man. Shit, guys. Shit. Fuck. Hey. All right. I'll keep it simple here. Let's grab the outer edge. Shift D that, separate it, see where it ended up. So that's the bicep. There it is. And let's get rid of some of these bools. Okay. Extrude it that way. And I'll use the solidify modifier just to generate the 1 mil offset. Oops. So I don't want the rim there. So you can see these faces intersect. So let's see if we can do that. Okay, actually we got some clean results here. See what that looks like. It looks pretty clean. So the outside I'm gonna delete. Okay, we don't need that anymore. We use this to generate the inside, the shell. And now let's use this do that one with 5. Make sure the geometry is alright. 5. So here's our shell object. So yeah, this is my little workaround coming from a CAD background. I like to see consistent results. So there's the shell. And yeah, if you do solidify, you might be contending with this, and that's going to show up on the inside of the shell of the wall. But yeah, let's cut this bicep shell object. And what I like to do is I'll parent this just so that when I move the bicep around, the shell object moves with it. And it didn't work. That's interesting. Oh, you know what? The normals must be inverted. Let's try it again. There you go. You have a 1 mil thickness. Pretty roundabout way to do it, but yeah, I like the results I get, so it's okay. Um, it's the bicep. Oh yeah, the cross section because I want to work on the inner bicep. Outer. Boolean. Bicep shell. So yeah, we have this thing size for size. It's gonna be a press fit. Maybe let's add some bevels to the corner so we don't interfere with the corners. And all right, so it's time for me to hide the rest of the. It's time for me to hide the rest of the Gundam here. Skirt, legs, neck. Cactus shoulder. There's the deltoid on the cactus side. The hand is a reference. And the head, yeah, just to clean up the viewport here. So we have the bicep piece. It's gonna slip on, and I noticed on the high grade Gundam that there's ribs. There's shortened ribs that act as stops. Makes sense in a second. Let's see. So this elbow B we don't need to worry about because man, I need a drink of fucking water. I've been yapping for like an hour. It's crispy. Oh my god. That's crispy as hell. Don't dox me. How hot's my laptop right now? Brave. Blender. Yep. So I want the bicep piece to be a slip fit on to this green piece here. In fact, let's go back to object. Just gonna start coloring some things just to stay organized. Oh, I'd like to show you guys how I do my panel lining. I think that'd be interesting to learn my method. It's pretty cool. Sometimes it gives good results like this, and then other times it's kind of shitty. Depends on the surface you're cutting. But yeah, there are a couple of different methods to do it, but this one I kind of coined is pretty cool. So this bicep is gonna slip over, and there's gonna be ribs. Active. What? Why is it? Oh, what? 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 Cursor to selected. Let's add a plane. Let's do a 1 mil. 1 mil by 1 mil. So it's gonna be buried into the wall a little bit. So let's do a another 0.5 here. Oh, it crashes. Crashes with that. I like seeing measurements. There's a couple ways I do measurements. It's 3, 4, 5. How thick is that wall in here? It looks like a mill. So it's a mill tall. It's a mill wide. I can put it in the corners though. You can put it in the corners. So instead of a rib that acts like a stop, it's gonna be like a Lego like cross. So imagine that, something like that. Hey, okay. It's gonna A, act as a stop, and B, secure it in place. Okay. I mean, the slip fit is already pretty good, so I don't know. We have this here. Let's take a measurement. It's 0.5. Delete all. So we're in this corner here. And what do I want? How big is a 1 mil by 1 mil? Let's take a measurement. That's 1 mil. That's another mil. Just gotta think about the sizes. I guess right now it doesn't really matter. I'll do a yeah 1 mil by 1 mil cube or rectangle. Why does it not look straight? Is that planar? Oh my god. That's wise. Okay. Something wrong with the shell object. Bicep. Not this one. No. Is this thing not straight? Oh, my computer's going crazy. Alright. I'm gonna keep working, but I'm just gonna end the stream. See ya.